Hi everyone, welcome to all of you on my YouTube channel. So here I am going to start the PYQ series of drying mass transfer. So already you can see I have uploaded lots of PYQ series of different topics. Let's say distillation, humidification, again process calculation, and non-ideal reactor, non-isothermal reactor, heterogeneous catalysis system. So you just go and watch all of these videos from PYQ series. You will get benefited a lot in GATE 2025. And I'd like to request you, if you have not shared my YouTube channel with your colleagues, please go and try to share with someone else also, so that that people will get benefited from there. So before wasting our time, so let's start with the question here. That I'll try to complete the whole questions in one lecture, but if I won't be able to complete, then definitely I'll be making another video to complete that whole topic. So here you can see in laboratory runs, this question has been asked in GATE 2000 having 2 marks. So this question says that in a laboratory run, the rate of drying was found to be 0.5 into 10 to the minus 3 kg per meter square s. So rate of drying is given, that is 0.5 multiplied with 10 to the minus 3 kg per meter square second. When the moisture content reduced from, let's say moisture content x1 was initially 0.4, and let's say second moisture content, it is reduced to 0.1 on dry basis. So when we talk about the wet basis and dry basis, so when I am writing capital moisture content, I mean moisture content in capital letter, that is x1, that is on the dry basis, capital x1, and if I am writing in a small x1, that is on the wet basis. So the critical moisture content xc is also given to you, that is your 0.08, and a tray dryer is used to dry 100 kg of the same material under the identical condition, right? And the surface area for the moisture is this one. So SS by A, that is given 1 upon 0.04, that is equals to 25 kg per meter square. Then the time required to reduce the moisture content. So earlier, here you are supposed to calculate what is theta when moisture content is being reduced from x1 equals to 0.3 to x2 equals to 0.2, this one. So in earlier cases you can see, so here what we can see, that if I want to write theta, so theta can be written as obviously SS divided by A NC into obviously x1 minus x2. Let's say this one is equation first. So here the moisture content is being reduced from 0.4 to 1, 0.1 on dry basis. The critical moisture content is also given, and HDI is used to reduce these things. The time required to reduce the moisture content of the solid from this one to this one. So SS by ANC is given to you, something like that. Okay, and N is also given. So now you can directly calculate this thing. So we can directly calculate these things, that theta, that is SS by ANC is 25 divided by N is a kg per meter square second, that is 0.5 multiplied with 10 to the minus 3, and moisture content is being reduced from 0.3 to 0.2. Is that clear? So now we can directly calculate theta is equals to 250 divided by 5 multiplied with 10 to the 3 into 0.1. So 550, and obviously theta can be written as 5000. So from here your option C will be your correct answer. Okay. Now moving towards the next question, the question says that 200 kg of solid on dry basis is subjected to a drying process for a period of 5 seconds. So theta is given to you, that is your 5000 second. The drying occurs in a constant rate period, and drying at a constant drying rate at constant rate period, or this is given in constant rate period is kg per meter square second. The initial moisture content of the solid is this one. So capital X1 is 0.2. The interfacial area available for the drying is this one. So for if I want to calculate SS by A, that will equals to 100 by 4, that is equals to 25. The moisture content at the end, that is x2, is equals to what? So this is happening in a constant rate period only. So directly I can calculate the x2 value. So I can write the formula theta is equals to SS divided by ANC, and obviously x1 minus x2. So theta is given to you, that is your 5000, right? SS by ANC is your 25 divided by ANC is 0.5 multiplied with 10 to the power minus 3 multiplied with x1 is 0.2 minus x2. So you are supposed to calculate the value of x2 here. So let's try to calculate this thing. So here you can say that 2.5 divided by 25, that is equals to 0.2 minus x2. So that is so 0.1 equals to 0.2 minus x2. So the value of x2 will be equals to 0.1. Is that clear? So from here your option C will be correct. Now moving towards the next question. The question says that it takes 6 hours to dry a wet solid from a moisture content to the critical moisture content of 15%, right? So let's say theta 1 is equals to 6 tower, and obviously xc is given to 0.15. How much longer it will take to dry the solid to 10% moisture content under the same drying condition, right? And if equilibrium moisture content x star is given to you 0.05. okay, and obviously x1 is given to 0.50. So if I want to calculate theta 1, so theta 1 can be written as obviously SS divided by ANC and x1 minus xc, right? And if I want to calculate theta 2 in falling rate period, let's say, because equilibrium moisture content is also given and critical moisture content is also given, so I can write SS divided by ANC xc minus x star ln xc minus x star divided by x2 minus x star. So here you are supposed to decrease the moisture content up to 0.1, right? So now if you can write this thing, so much time required in first period is 6 hours, so I can write 6 divided by theta 2, it will get cancelled out. So that is 0.50 minus 0.15 divided by 0.50 minus 0.10, so moist 0.05, and ln xc is 0.15 minus 0.05 divided by x2 is 0.10 minus 0.05. Is that clear? So directly you can get 6 divided by theta 2, and that is equals to 0.35 divided by 0.35 ln 0.10 divided by 0.05. This will get cancelled out. So finally you will get theta is equals to 6 multiplied with ln 2. So once you will calculate these things theta 2, so you will be getting 1.18 hour, something like that. I think I have done a mistake here. It should be 0.15 minus 0.05. Okay, so again you have to do the calculation. It's a very simple thing here. So now you can get here 0.10 ln 0.10 divided by 0.05. So theta 2 can be written as 6 multiplied with 0.1 multiplied with ln 2. So here you can say that 0.1 2 ln multiplied with obviously 0.6, that is equals to that is 6 in hour. So you have to convert into minutes. So also you have to multiply with 60, because the question you are supposed to calculate in minutes. Okay. Okay, I'm really sorry. Here you cannot, you have to write 0.35 as well. So it will get divided by 0.35. So approximately you will be getting 71 minutes. So again, I'll suggest you do the calculation correctly. Definitely you are going to get the answer. Now the next question is that a solid is being dried in the linear drying rate period from a moisture content x naught to xf. So the drying rate is 0 at x is equals to 0. So means x naught is the initial moisture content, xf is the final moisture content, and m is given as ls divided by arc, and this is happening in a constant rate period, no falling rate period. The drying rate is 0. The critical moisture content is same as the initial moisture constant. So xc is equals to x naught, that is given to you, and equilibrium moisture content is 0. So if I write the formula, the time required, that is equals to ss divided by anc into xc minus x star ln xc minus x star divided by xf minus x star, right? So here you can see x star is 0 and x is equals to x naught, and this one is given as m. So theta can be written as m x naught ln, obviously x is x naught and 0, that this is divided by xf. So this one will be your correct answer. So from here you can see that is m x naught ln x naught by xf. Your option D will be your correct answer. Okay, this is just a formula based question. Now I'll be moving to ask the next question. This is a really good question. So the question says that a 25 cross 25 cross 1 centimeter flat sheet weight 1.2 kg initially was dried from both sides under the constant drying rate condition. It took 1500 seconds for weight of sheets to reduce from 1.05 kg to 1.05. So you have two sheets, something like that, right? Something like that, right? So here you can see this looks like in this way. Again there is this one, again this one is looking like that. Okay, so this is sheet 1 and this is sheet 2. Here dimension is 25 cross 25. So here area of this particular thing will be A1 is equals to 25 cross 25 into 10 to the power minus 4 meter square. Here area is equals to what? 1, because this is 1 and this one is 1. So area is 1. But here drying is happening with both the surface. So here this green with this green surface, both of these surface. But here in this case you can see drying is happening only due to only one surface, that is yellow surface. Is that clear? Drying is happening only here due to this, and here drying is happening due to this surface and due to this surface. So here you can see, if I am assuming is area is A1 and area is A2, so total area A total, that will be equals to 2 multiplied with A1, and here what is area? A total will be equals to only A, that is equals to 1, and here it will be 2 multiplied with 25 into 25 into 10 to the power minus 4 meter square. And in this particular case theta 1 is given to you, and that is equals to 1500 second. And here you are supposed to calculate theta 2 is what, but here moisture content is being reduced from x1 to x2, so 1.25 to 1.05. so here this one x1 is 1.25 and x2 is 1.05. okay, and here it is being reduced from x1 dash is equals to 19.2 and x2 dash is equals to 17.6, this one. Okay, so this is very simple question now. So now you can write this formula, theta is equals to ss by anc and x1 minus x2. So you can say theta is directly proportional to so in both of these cases you can say that initially ss by a is there. So earlier area was different, and in both of these cases area is different, right? So that is directly proportional to x1 minus x2 divided by area. Is that clear? So I can say theta 1 divided by theta 2, that is equals to area 2 divided by area 1 multiplied with x1 minus x2 divided by x1 dash minus x2 dash. So all of these things already I have written. So theta 1 is given to you, that is your 1500 divided by theta 2, and a2 is what, 1, and a1 is what, 2 multiplied with 25 into 25 and 10 to the power minus 4, so that is equals to 10 to the power 4 multiplied with x1 minus x2, so you can say 1.25 minus 1.05 and divided by 19.2 minus 17.6. So from here one can calculate the value of theta 2 directly. This is very simple. Okay, so all of these questions are based on only formula. So if you know the formula, then definitely you will be able to solve the question. But again, you have to understand how this drying area is being decided. So you have to decide the drying area where only drying is happening through one area and where drying is happening due to the second area. Okay, so coming to the next question, again the question is similar, but again only you have to understand the area. So again you have two samples for drying here. You can see this one is first one, and again this one is the second one. Okay, so here you can see that in first case the 50 cross 50 thing is there, and in another case you can see that 1 cross 1 is there. So this, if I say 1 cross 1, this area, and here again this one, this green one is 50 cross 50, but drying it from both sides. So here area is, let's say, a1 and area is a1, so drying is happening due to both areas, so a total will be equals to 2 multiplied with a1. So you can say that is 2 multiplied with 50 into 50 into 10 to the power minus 4, because this is in centimeter, right? Now here what is area? So this here drying is happening only due to one area. It took 100 seconds from one side only. So what is area here? Area is 1. So now I can write that is theta 1, that is equals to SS divided by A and C into obviously x1 minus x2, and this is A1, and theta 2 is equals to SS divided by A2 and C, because SS is same for both of these material, and again x1 dash minus x2 dash. So let's say this one is equation first and this one is equation second. So if I'll divide this thing, so I can write directly theta 1 by theta 2, that is equals to A2 divided by A1 multiplied with x1 minus x2 divided by x1 dash minus x2 dash. Okay, so theta 1 is given to you in the problem, and you can say here that is 1000, and you are supposed to calculate theta 2. So let's try to write theta 1 is 1000. So I'll substitute this thing directly here. 1000 divided by theta 2, and area 1 divided by 2 multiplied with 25, sorry, here it is 50 cross 50. So I can write 50 into 50, 10 to the power 4 into. So initial moisture content was 1.75, and it is being decreased from 2 to 1.75 and 4 to 1.3. So 2 minus 1.75 divided by 4 minus 3. It's very simple calculation. Now you can calculate these things very easily. So once you do the calculation, you can get theta 2, that is equals to 500 divided by 0.25. Okay, so again from here you can get 100. So you will be getting answer is 2000 second. So this is in second, yeah, so you will be getting a 2000 second answer. Okay, so with that I'd like to end the lecture here only. From the next lecture onwards I'll be starting with question number 7.7, and in one more lecture I'll be able to complete this drawing, and after that I'll be starting with the PYQ series of absorption. Okay, thank you. So I'll try to complete the whole mass transfer operation within second Feb, and after that I'll be starting with the PYQ series of fluid mechanics. So I'll suggest you to watch all of these video. Already I'm discussing all of these concepts, and in very fast way you can read and see all of these video, and you can get good idea about how to solve the questions in examination. So here you can see also I am skipping lots of steps for the calculation, so this is also required in the GATE examination if you want to get good rank and all. Okay, thank you all.